In our previous video, we were looking at confidence intervals for means where the variance or standard deviation of the population was not known. So we were using the student's t distribution. Now, if you're going to use the student's t distribution, you need to test the assumption of normality. So with the confidence intervals for t, they use t distributions. The assumptions are that you have a random sample, the population is normal, or the population is not normal and the sample size is large. We also are using the t distribution because the variance or standard deviation of the population is not known. Well, you should know how the data was collected, so you know whether or not it's a random sampling method. And we state here we don't know the variance or standard deviation of the population. So we should check the normality of the population, especially if we have a small sample size. So let's take a look at an example and look at how we would do that. So to test the normality assumption, you're actually going to create what is called a QQ plot. This can test whether the population is normal by looking at whether the sample is close to normality, because we know that if the population is normal, then the sample will be normally distributed as well if it is a truly random and representative sample of the population. So how a QQ plot works is it plots the quantiles. So recall that we've talked about quartiles. We talked about the interquartile range. We took Q3 and Q1. That was the quartile, so 25%, and quartile 75%. Well, here we're looking at quantiles, and quantiles made up of both quartiles, the 25, 50, 75%, but also can look at 10%, 20%, and other types of percentiles. So it's looking at, is there a normal distribution when we plot these quantiles against the quantiles from our sample? So how does a normal distribution look in terms of how it breaks down the data versus how our sample breaks down the data? If the sample is normal, then the data point should fall along the 45-degree line in our QQ plot. So what you see here on the left is a QQ plot where we do not have normality. So notice how there's a curve to this data. This data has an exponential growth, and we'll talk more about that when we talk about forecasting methods. But a QQ plot that shows normality will have all of the data kind of randomly scatter around this 45-degree line. So we can create a QQ plot to test our assumptions. So let's take a look at this particular example here. So the FBI compiles data on robbery and property crimes and publishes the information in population at risk. A sample of a recent year's pickpocket offenses yield the values of losses shown below. Use the data to obtain a 95% confidence interval for the mean value lost. So if we were going to do this in Excel, we would take our data, here's our list of loss, and we could use our equals confidence to create our confidence interval. Now in this particular case, notice we know nothing about the population in terms of its distribution, in terms of its standard deviation. So if we're going to do a confidence interval, we're definitely going to do a confidence T in order to create that confidence interval. When you do a confidence T, you need alpha, the standard deviation, and the sample size. So we have our data here. Unlike in the previous example, this is just all the raw data. So we would need to find the standard deviation of the sample. The other thing is that once you have that margin of error, we need to add it to the point estimate, being the sample statistic, the average of this sample here, to get the upper and lower bounds of the confidence interval. So if we're going to do this fully in Excel, one thing we can do is we can use data analysis to have it give us the descriptive statistics. So to get this data analysis tool pack, you can, if you are on a Mac, you would go up at the top. This is the part you can't see, but you would select under Tools, you would see it says Excel Add-ins, and you go to Excel Add-ins and you can install the Analysis Tool Pack. If you are on Windows, then you have a tab to the left of the Home tab go click on that and then go to options, and then you can do add-ons from there to install that data analysis tool pack. That data analysis tool pack, under the data ribbon, we have our data analysis tool pack, and it has a function called descriptive statistics. So if I click on that, descriptive statistics, and I have to highlight the input range once I'm inside of this virtual basic add-on, and I can have it do a new workshop. Really what I want is for it to give us the different summary statistics. There we go. All right, so what this does is it summarizes the information. So here we have X bar, and here we have our standard, here is our standard deviation of our sample. Let's just make this a bit bigger here so we can see it properly. Okay, and from this then, our point estimate for our confidence interval is our X bar. So that's going to be our point estimate here. And then what we would do is we would then want our margin of error. Gotta learn how to type here. Margin of error. And we can use our confidence T to get us that margin of error. And then we need to give it alpha. So if we're doing a 95% confidence interval, we put in alpha of 0.05. We need standard deviation. So that is this number that is right here for our sample. And then we need to know sample size. And so you'll notice the bottom of this descriptive statistics, it tells you that the sample contained 25. So we get a lower bound, point estimate minus margin of error, and an upper bound, point estimate plus margin of error. So we have our upper and lower bound. This is similar to what we did previously. The difference between this and what we did previously is we just gave you the average and the standard deviation. Here you are pulling it from the original data set. Now, in order to test the assumption of normality and the fact that we could use this t-distribution, then we need to create a QQ plot. Well, part of the problem with using Excel is Excel does not create a QQ plot for you. And that's why when you're talking to statisticians, they're not really using Excel for their data analytics. They're using JUMP or SPSS or SAS or R or Python. All of these are statistical software that does a lot more than Excel. Well, what we're going to do is we're going to start showing you how to do things in Python. Yes, you can do them in lots of different programs, SPSS and SAS, but those cost lots of money. You can do it in R, which is kind of my favorite, but we're actually going to teach you in Python because Python has other uses besides statistics like machine learning, artificial intelligence. You can even make apps and code other computer programs with it. So it has greater functionality even beyond data analytics. So we're going to use that one so that as you learn the language, you're able to do even more with it. And as we move into machine learning and our descriptive, diagnostic, predictive, prescriptive analytics, we're going to be doing more and more Python. So we might as well start now. So what we're going to do is we're going to show you how to build a QQ plot and do exactly what we just did in terms of our confidence intervals, but in Python code. So if you're going to do this in Python, the first thing we're going to have you do is have you go to drstephpowers.github.io/BIA. If you're going to work with me through the videos that are descriptive, diagnostic, predictive, and prescriptive analytics, if you're doing machine learning with my videos, all of the workbooks can be found here at drstephpowers.github.io/BIA. And this is where you find the workbooks that go with my business intelligence and data analytics handbook. Today, we're actually going to be working through the supplemental material, and we're doing confidence intervals. To get yourself started, click here. And what you're going to then do is you are going to click on Open in Colab. This will then open in Google Colab, which is an app inside of your Google Drive. The other thing you'll need to do is go here to Data, And you will see here it says statistics. Just move this up a bit here. So click on statistics and then click right here. This will download the file. Dump that into your Google Drive. So if we download that and throw it into a Google Drive folder, we can then reference that as we pull the data set. So the next couple videos, we're going to be using statistics and statistics 2. So for each of those, download them and then go to your downloads folder, drag and drop them into a folder or location in your Google Drive. Now, the other thing you're saving to your Google Drive is this supplemental stats workbook. So click open in Collab. When you do that, it will take you inside your Google Drive to this workbook. And what's important to do is to save a copy in your drive so that you can run the code and amend the code. Okay, so save a copy to your drive. So you might want to create a folder, call it stats, throw in those 2 Excel worksheets, as well as this into your Google Drive. So if I do that, here I am. Oh, been away too long. All right, so I'm logged into my Google Drive. I can tell because my face is up on the top. And what you're going to do is you're going to link this workbook to your own Google Drive. Okay, so this is connecting your copy of this workbook to your Google Drive so you can pull those Excel files. So what you're going to need to do is first run this. This imports pandas as PD and numpy as NP. PD or pandas is going to allow you to do things like import Excel files. So we want to make sure we import that package. And then we'll import numpy as NP because when we're manipulating data like dropping the empty cells, we'll need to be able to use NP. So it's always a good idea to import pandas as PD and import numpy as NP as your first step. Then what you're going to do is click this code right here from google.collab, import drive and mount. So this is then going to ask you for permission to link your workbook to your Google Drive. And so I have recently maybe I'll just interrupt my session here so I can restart it. Restart entire session. There we go. All right, because I'll show you what it looks like. So we import. Okay, so then I'm going to link it and it should, oh, it's still just remounting it. It'll pop up a display that says, this is your Google Drive. Do you have permission? Give it permission, say yes, say continue, so that you can mount to the drive. That is going to allow you to import a data set like the FBI one we were just looking at, so we can bring it in to Python. Now, when I bring it into Python, I'm going to read an Excel file. So it's going to use pandas, that's the PD, .read Excel. So it's going to pull it in from Excel. And I need to tell it where I put it. So in terms of my Google Drive, so if I create a folder, here I have a folder called BIBA Handbook, and I have a folder called Appendix. And inside there, I have dropped my statistics 1 and 2, and I have also have my workbook here. These don't have to be in the same spot. We just need to tell this workbook how to get to these 2 files. So the way you do that is you first link your Google Drive, and then the next is to say, here's where you will find that Excel file. For mine, it's inside a folder called BIBA Handbook, inside a folder called Appendix, and that's where you find statistics.xlsx. So for you, this part here is what you'll replace with the name of a folder that you have in your Google Drive, or if you have a folder inside a folder, then you'll have a slash like I do, because Appendix is a folder inside the BIBA Handbook. But the rest of it, the parts on the left to the highlighted area, and the parts on the right, you'll leave as is. So we're going to import it, and then I want it to pull just the tab called FBI. Here, when we were dealing with our data set in Excel, our data here was in the tab called FBI. And so I want it to pull just the data that is in the sheet named FBI. If I do a command called head, it's going to pull the first 5 rows of my spreadsheet. So X is what I called the data set, and I'm going to have it give me the head of that data set. So X dot head gives me the first 5 rows. So what I want to do here is create that same confidence interval that we did in Excel. To do that in Python, we're going to import a package called skippy.stats, and we're giving it a name. So we're going to simplify it. We'll just call it stats. And now we can call commands that are inside that package just using the name stats and not having to write out skippy.stats. So we import the package that has the commands we want. And we want to do a confidence interval using a t-test. So that's why it is t.interval from our package stats. And here we're going to specify that we want a 95% confidence interval. Now, when you do the stats.t.interval, you can see stats.t.interval. Doesn't like that. All right, so what are the parts of stats.t.interval? Getting you too used to R. An R where you just kind of it'll give you the example code. Here you can Google it. But stats.t.interval, first you specify the confidence interval, 90%, 95%, 99%. Then the next thing we're going to specify are the degrees of freedom. The degrees of freedom are n-1, n being how big our sample is. So there's a command called length, which will take your table here, X, and tell you, so if I add it here, add code, I can say, give me the length of X. And what it will do is it will tell me that my data set has 25 records in it. So that's what we're doing here is we're saying, okay, use this command length to find the length of our column called loss from our data set X. So the hard bracket and then the word loss is the name of the column. The data set is X, and we are then getting the length of that and then subtracting 1. So n-1 is our degrees of freedom. Comma, and then what you want to do is you want to tell it that you want it to find the average of your sample and the standard, the margin of error for your sample. So here we're doing numpy and having it find the mean of that column called loss. And then where it says scales equal, we're going to use our Skippy stats function and something called SEM to find that margin of error from the column loss. So when we do this and we click it in, what we find is the lower bound is 405 and the upper bound is 621.56. And I'll just go back to our Excel here. So you can see here's the 405 and the 621.6. So we can use Python to do the same confidence interval that we just did in Excel. The key here is that if you're using this formula with your data, so let me just make it a little bit bigger here. Gonna make it bigger. Problem with switching between Macs and Windows is the shortcut keys don't match. All right, where is my stupid little zoom? Zoom in. There we go. Okay, so if you're doing this with your data set, make sure it is to the name of your data set and the sheet name of your data. Bring it in. Rest of this code is the same. If you type in .head, it will show you the top of your spreadsheet, so you make sure it looks right. You're still going to need the same package. Then when you do this command, the only thing you would change is where it says X loss. This is the name of your data set and the column that you're analyzing. The rest of this stays the same, just trade out the name of your data set and the column you're analyzing. So you can use this code just as it is to find a 95% confidence interval for your data. If you want to change it to 90%, We just change that to 0.9 and we get the upper and the lower bounds. So in Python, you can get that same confidence interval for means using the t-distribution as you do in Excel with really just this one line of code. The benefit, though, of using a statistical package like Python, or of course you could use SPSS or SAS or JUMP or R, is that we can get this extra information to test our assumptions. We can create a QQ plot. To create a QQ plot in Python, we're going to need matplotlib.pyplot. That's what we're going to use lots to build our graphs as we move through more Python code. And we're going to call it PLT for short. Just makes life easier. Then we're going to import something called statsmodels.api, and we're going to call it SM for stats models for short. So these are the packages that will give us a QQ plot. Inside this statsmodel.api is a function called QQ plot. So we can create a figure that is a QQ plot using the package SM, and we are going to have it create a QQ plot from our data. So the idea is that if the population is normal, then a random sample will also be normal. So we're going to do X loss. So the name of our data set is X. The name of the variable we're looking at in that data set is the loss one. We're going to use stats.t. So this is going to compare our data to the t-distribution. Okay. This stats.t is using the stats package that you used from your confidence interval. Okay, so same package, that's why we can use the stats, and it's going to take the t-distribution from that stats package. Fit equals true, line equals 45, and then show the plot. plt.show open close parentheses. When you do that, you get a QQ plot that looks like this. Remember that our normality is when our sample quantiles, so that's from our data set, match the theoretical quantiles associated with a t-distribution. That's why you have to specify that it's a t-distribution here. In which case, if they match, they should be along a 45-degree line, which is what we see here. And so this matches the discussion that we had previously, right? This is a normal, and this would be an example of something that is not normal. To give you a bit of a comparison, these lecture videos I originally built to teach people how to use JUMP. And it would create a Q plot that looked like this. It created confidence intervals that look like this. So you can see whether I'm using Python or JUMP, I can get the QQ plot to test that normality assumption. Using JUMP or Python or Excel, I can get the confidence interval itself. But we do want to make sure that if we are using a t-distribution, that we have held to the assumptions of a t-distribution, which include the idea that we have normality. So either our sample is normally distributed or we have a big sample size. And so if we don't have a big sample size, make sure you're using a QQ plot to test your normality assumption. All right, let's go back. You can find here, so we have in that same data set, a data set called calcium. So I can import that in, make sure you find where it's located in your Google Drive. I've named it X2 here, which means I can do x2.head, open parentheses, close parentheses, to then look at the first 5 rows. And so we have calcium here. That particular data set looks at the most abundant mineral in the human body. It has several important functions. Most body calcium is stored in the bones and teeth, where it functions to support their structure. Recommendations for calcium are provided in dietary reference intakes developed by the Institute of Medicine and the National Academies of Science. They recommend adequate intake of calcium for adults, that it's 1,000 milligrams per day. So we could look at, is it reasonable that people are getting 1,000 milligrams per day by constructing a confidence interval for the data. Here's our calcium. You can't see that because that's super duper tiny. Here's our calcium. In Excel, we could use our descriptive statistics, and we could use our confidence T formula to find the confidence interval. Does it contain 1,000? Alternatively, we can do it in Python, just like we did previously, using our skippy.stats and the command stats.t.interval. We could then check that normality assumption by creating a QQ plot for this calcium data. So give that a try and see if you can perform this in Python and Excel. But first, maybe I should just give you a little bit more instructions, which is we have a sample of 18 adults with incomes below the poverty level. We have their daily calcium intakes. And we want to know, is a 90% confidence interval for the mean calcium intake of adults with income below the poverty line. Also create a 99% confidence interval for adults below that poverty line. And then the question becomes, is it reasonable to say those below the poverty line are getting the adequate intake of calcium of 1,000 milligrams per day?